Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is an old friend of open source, of the RTC community, of the conference circuit, Dan Jenkins from England. Thank you for joining us today, Dan.
Thank you for having me, Luca.
Well, I think literally everybody was in the audience knows you, but just in case, would you like to give us an introduction to the three people who have been living under a rock?
You'd be surprised. I still meet people that don't know who I am. Shocker, I know. Dan Jenkins. Who is Dan Jenkins? So I run a consultancy business in the UK called Nimble Ape Limited. So we do consultancy around anything open media, real-time media, that kind of stuff. So whether or not it's WebRTC, whether or not it's media over quick, whatever that is, web stuff, VoIP stuff, etc. I also run a conference called CommCon in the UK, but we literally just had our first US version a couple of weeks ago, and then there's another business as well called Everycast Labs, and we've got a product called Broadcast Bridge that makes bringing in remote people into AV stuff much easier than it used to be. So yeah. We've got a lot going on. Is the short answer. And then we've just added something else that we're going to talk about today, hopefully.
Absolutely. Well, yeah, you surely are busy, man. So, but you probably had a few hours open between 2 a.m. and 5 a.m. So you decided to build this new project that's called IcePerf, which is really interesting to me because I've been dealing with issues that it can help with this last few days. So what's IcePerf?
IcePerf. So the little bit of a background story, is the fact that we as a consulting business were kind of always telling customers who was the best turn provider, who was the best turn network for them. But ultimately, it was all very much like, a guess. It was a feeling. Like, oh, this customer's based in Europe. So, and, their usual customer base is in healthcare. And so the wild stab in the dark was the fact that, say, Twilio's turn network was best because lots of healthcare professionals and institutions already open up their firewalls to a load of Twilio IP addresses. And so magically Twilio turn would work, right? But it was all very much a gut feeling. And we were like, well, why are we doing gut feelings? Let's get some data. What data is already out there? And as it turns out, there wasn't any data out there. Not really, not public data. So we ended up building IcePerf.com. So let's rewind just a little bit. Turn networks. What's a turn network? So turn is used for an awful lot of things, but most commonly today, it's used for WebRTC. At least for us, it's used for WebRTC. And so, even though we're currently talking via a WebRTC service, we're not actually talking peer-to-peer, as in two clients. I'm talking to a server and you're talking to a server. And so 99% of the time, that works absolutely fine. You don't need anything in the middle. But what if you're on this tricky network? Usually it's healthcare or government or financial. They're the top three that are tricky. What if you're on one of those networks and you go to make your connection to that WebRTC server and it doesn't connect? Well, that's where a turn server comes in. You put the turn server in the middle, and then it relays your traffic. You connect to that instead, and then it relays over to your server. So there's a lot of kind of tricks that we put in to try and to make all of that happen seamlessly. And that's where like turn networks come in. So obviously you don't have to use a turn network to run your WebRTC service. Lots of services co-deploy their own turn network against side by side with their media servers. But ultimately, if a client can't talk to that that server anyway. It doesn't matter whether it's more than likely that it's going to fail anyway, talking to a turn server that you've co-hosted anyway. So that's where like these turn networks come into play, because there are only a couple of them. And so if you're using Twilio, then Twilio has already had their IPs kind of whitelisted by a lot of entities. So yeah, long and short of it is we started off buying relayperf.com and turnperf.com, because we were like, let's test these turn networks. And then kind of the more and more we got into it and started thinking about it more, well, turn, at least for WebRTC, is part of the bigger ICE process. So why are we just testing turn? We could test loads of things to do with ICE. And so we ended up buying IcePerf.com. Hold on, here we go. DNSperf.com. DNS.com is not what I wanted. DNSperf.com. DNSperf.com. So this is kind of what we want to end up kind of giving to people as an end result. You go to a page and you get told who is the best DNS provider. And so you can see there in the world, Cloud DNS is the best supposedly, and Cloudflare is second. But if I change this to say Europe, or even more specific, let's change it to the United Kingdom. Well, Cloudflare is now 8th. So it's very, very specific to location, right? And this is the kind of level of stuff that we wanted to get to with IcePerf.com. So yes, that's the beginning story of IcePerf, and we do a couple of tests. We do 3 main tests today, with 3 main tests today, and then we've got a couple more coming soon, and then once we kind of got to a happy place with testing turn, then we'll be going after CPaaS providers as well. It's been an incredibly interesting project. Like you would think, well, how much is there to really test when it comes to a turn network? Like, you know, you send data to it and then it relays it. What is there to really test? But the more that we've got into it, the more we've got into it, the more you realize just like what we can test and what affects the end result. So let's talk about who we actually test today. So we test Cloudflare. So you'd be forgiven for thinking a couple of years ago that there were only really 2 turn networks in the world. One was Twilio, and one was a company called Xersys. And that's pretty much been the case for a long while. And then I think...
And I have to say, we discovered Xersys late. Like,
right.
I used the Twilio stuff for a long while.
Exactly. And then we had pre-pandemic, Subspace launched their turn network and kind of promised these best ideals of, oh, well, we can ingest data in one place and then we can egress it in a different place, and that will kind of reduce the hop on the public internet. But unfortunately, Subspace ended up dying as such, and we were back down to 2. But the thing that actually spurred us to start looking at IcePerf.com was Cloudflare. They announced that they were going to be doing a turn network. And anyone that knows anything about Cloudflare, they've got something like 320 different POP locations all over the world. And other than a few of them, their turn network runs in every single one of them. And then they announced that their pricing was going to be 5 cents per gigabyte, and it only gets charged on the way out as well. For comparison, Twilio, I'm not sure how many regions they've got off the top of my head, but let's say 8 or 9. I can't remember.
Yeah, it's
exactly.
not more.
It's not a huge amount, right? We're talking low under 10, or maybe low slightly above 10. It's not more than that. So they've got a lot less regions and well, a lot less points of presence, and they charge 40 cents per gigabyte, not 5.
Wow.
And they charge on the way in and they charge on the way out. So, you know, that's terrible maths, but let's just say it's 80 cents per gigabyte compared to 5, and there's less regions, less places. So then you can start seeing, well, this is why we started wanting to look at real data, because up until, say, Cloudflare, well, Xersys only had so many regions. And, well, in the process of doing IcePerf.com, well, we found express turn and we found metered as well. So we've now got five turn networks. But most of them, you know, operate on the same kind of basis as Twilio does, a small number of servers. So Cloudflare kind of entering the market kind of changed the game, let's say. And so that's kind of what led us to wanting to be able to see what kind of effect that has. Does it actually have any effect at all? Right? Like we just didn't know. So let's take a quick look at the general tests in that we do. So we do a latency test. What is a latency test? Well, it's time to first byte through the turn server. So the agent that does the test is open source. It's on our GitHub. It's called IcePerf agent, and you can go take a look at all the code that actually runs these tests, and you can go, Dan, that's not doing what you think it does. So latency, we start up two WebRTC peer connections, and it's written in Go, uses Pion. So it creates 2 different ones, and then we give it one ICE server, a turn server, and we force one of those connections to go via turn. And then we give the other one the Google Stun server. And then that way, and then we push data through the turn server. So it kind of, you know, it boomerangs back to us via to the second peer connection. And so then we send data, and then we test, right, how quick was it to actually getting a result back, to getting that block of data back. And so this UI is changing a little bit. We're making it easier for people to figure out, right, who is actually the best? Because at the moment, that's just a load of text, and you kind of have to work it out for yourself. But you can tell that Cloudflare on turn UDP takes 24 milliseconds. So all these tests are done from my house. A slight aside on that. Well, where are all of your customers actually connecting from? They're connecting from home broadband connections, right? Or even you know, mobile connections. They're not connecting from a server that lives in the cloud that might have excellent peering connections to AWS or Cloudflare or whoever, right? Now, my ISP might have really great peering connections, but at least it's more, you know, representative of what we're actually trying to test. Longer term, we want to be running these tests from multiple places all over the world so that we can kind of figure out better, more general metrics, but we're not quite there yet. So yeah, you can see the Cloudflare takes 24 milliseconds on UDP, 24 milliseconds on TCP, and 23 milliseconds on TLS.
Nice.
And so these are averaged over 7 days. And then you can see the rest of them, 38, 35, 36, 38, 38, 37, 30, 28, 29, 151, 151. Oh yeah, I should say Express Turn is on their free trial. Everyone else is on, everyone else has given us credit. Express Turn, we haven't been able to kind of get in contact with the team there because obviously, we end up pushing quite a lot of data, so it ends up costing quite a lot of money. If you're going to pay for it, it would end up costing quite a bit. So yeah, you can see there from a latency perspective, I've got the best connection to Cloudflare. Well, is that strictly, is that because of where I am? Probably, because Cloudflare have, they have a POP in London. Where am I? I'm just outside of London. Whereas, say, Twilio, for example, they run theirs in, I think, Ireland and Frankfurt. I don't think they've got anything in the UK. And so that kind of explains that change, right? Which is why we want to get to testing from multiple locations. So that's latency, and like that's interesting, right? How long did it take for us to get data? How long did it take to go from A to B? And obviously, like, if all of your customers are in the UK, then Cloudflare is a really great offering, right? Based off of these tests, right? Because we tested from the UK. And so, but let's take somewhere like completely and utterly, you know, separate. South Africa. So I don't think any of these have any servers in South Africa, other than maybe Cloudflare. So where do you, if you were in South Africa, where would you want to connect to? You want to connect to a turn server that's closest to you. And so that's probably Cloudflare. So yeah, it just shows the importance of being able to run these tests from loads of different places. So it's an interesting stat, but at the same time, like, does it matter if it takes that extra millisecond to be able to get from A to B? It can do. Like, if you're doing a telemedicine type thing and you're controlling a robot on the other end, you know, 1, 5, 10 milliseconds, that's a long time, right? So it does matter. Throughput was a really interesting test. To be honest, it was a test that I kind of just wanted to shove in to see who performed the best. And again, Cloudflare ended up performing the best. So you can see there, over UDP, we were able to send 60 megabits per second on TCP. This is max throughput. On TCP, we were able to send 61. And then on TLS, we were able to send 70. And we're like, this is really weird. Like, how can that be the case? Because we're always told that TLS adds all of this extra overhead. So, you know, how are we able to kind of do this stuff? And but anyway, Cloudflare managed to give us 70 as an average over 7 days. And then you can see the rest of the results there. I think the second place was mostly Twilio. Metered offers better UDP, but then doesn't offer great TCP and doesn't offer great TLS, for example. So they're just interesting numbers. And then these are the ones that I think are the most important. And I think I need to move them to the very top. ICE candidate response time. So the top one here is if you can't see these stats very well in the recording, go to iceperf.com and then go to results.
Just a question for you, for the people who understand Turn but not quite. Why are those numbers more important than the top ones? I know why, but why is ICE candidate read time is the most important?
So this is actually why I liked renaming it to iceperf.com rather than turnperf or relayperf.com. ICE, at least for WebRTC, ICE is the most important thing when it comes to connectivity. It's what allows us to be able to kind of bypass firewalls and do proper peer-to-peer stuff. And ICE is kind of magical, right? But the thing that causes ICE to kind of be able to do what it does is what we call ICE candidates. And so it's where we go off to a stun server or a turn server. I'll come back to what the difference is between stun and turn in just a second. So it's where we go off to a stun or a turn server and say, right, how do I get to the other side? How do I, and that can be different ways. And then it gives you back a candidate, gives you back, right, this is how you're going to do it. And so this happens on every single WebRTC call, especially, and it happens multiple times. So if I'm on, what's a really good example? Well, a really good example is I'm on my machine right now, and I've got Wi-Fi, I've got Ethernet, I've got numerous VPNs, and so my browser, basically, when it goes and gets ICE candidates from a turn or a stun or return server, what does it do? Well, it goes off on every single possible path, including Wi-Fi, including Ethernet, including IPv6 versus IPv4, including all of those VPNs. And it goes, right, I want to go talk to that server, that WebRTC server, or that WebRTC peer. How can I go do that? And so the candidate that comes back the quickest is going to get tried first, generally. And that's generally going to be a stun server, and then it's going to be a turn server. So that's why ICE candidate response time is super important, because if it takes you, so let's say you're using Google's stun server, right? Well, let's say it's not performing very well. Ironically, it does actually perform really, really well. But let's say it wasn't performing very well. Well, that slows down every single call, every single session that you make through your service. And so if every single call setup time is increased by, say, 5 or 10 milliseconds, I mean, it's not the end of the world, but like, everyone hates waiting for a call to connect. And so ultimately, the quicker you can do it, the better. So I said I was going to come back to what the difference is between stun and turn. In the most basic form, stun is me going off to a stun server and saying, right, how did I talk to you? Because stun is a process where we kind of punch a hole through our firewall and go, right, here's my public IP address, and here's the port that, the other side can connect to me via. So it kind of punches a hole, and then that hole kind of stays open for a little bit. That's how stun works. Turn works by us going off to a turn server and saying, how can I route media through you, right? What's the port that I need to talk to, and the IP address that I need to talk to be able to send media through you, right? So that's the difference. One is kind of punching a hole through a firewall. The other is kind of, how do I relay media through this extra place? So that's the difference between stun and turn. So yeah, relay response times for candidates is really, really, really important. And so let's take a look at the stun one down at the bottom first. And this is really interesting. So Google, on average, replied with an ICE candidate 54.9 milliseconds.
Yeah. Google's usually good.
Google's really good. And so Cloudflare 71.8, Xerxes was 61. So remember, like, I'm closest to Cloudflare, right? You'd expect Google might have it running in the UK, maybe. So, am I closest to Google? Am I closest to Cloudflare? But the fact is, right, the difference between 54 and 71 is huge, right? So why is there that huge difference? And then, yeah, Xerxes 61, Twilio 60, Metered 65, and ExpressTurn 80. So yeah, Google's like flying compared to the rest of them. Because, like, I mean, even between 50, let's call that 55, and Twilio's 60, that's still 5 milliseconds. That's an awful lot in the grand scheme of things. And then relay ICE candidate response times. So Cloudflare 97, which was the quickest for UDP. Twilio 241, right? So where's that time difference? That's a huge time difference. Like even if we go to the next best, which was metered was 187 milliseconds. So it takes twice as long for me to be able to get that ICE candidate back from a turn server on metered as it does from getting it from Cloudflare. So that's UDP, TCP. So TCP, 150 milliseconds for Cloudflare, 244 for Twilio. So like, there's this huge difference, basically 100 milliseconds there. Metered was the next closest, 154. And then TLS, so Cloudflare gave us back a candidate in, on average, 200 milliseconds. And again, Twilio, 364. Whereas, again, the next best was metered, 276. So these tables are going to get far easier to read. So soon we'll have green and red for best and worst, and then we'll also have against obviously Cloudflare, like the best one in this instance was Cloudflare, but we'll put a percentage number against all of the other ones to go, right, Xerxes was X% slower, Twilio was X% slower. And so you can start forming an opinion. The problem with all of this data is like, there is no way for me to go, right, this is the best turn network for you, right? Just based off of the data. But this data allows people to be able to try and start to figure out what they're doing. And then something coming very soon, let's take a look at a provider specific page. So there's all the raw data for that provider with a nice graph for throughput. So you can see that they're all pretty much the same in terms of, so let's go take a look at Twilio. So you can see there, we actually tested 4 turn servers for Twilio because one of them, so that's a turn TCP, green is turn TCP. And so one of them will be probably 3478, which is the default port. And then one will probably be 443. Trying to do some of those tricks to get stuff to work nicely. So we actually test 4 for Twilio. But we're going to add at the very top here. We're going to try and start taking some of the knowledge that we've got as a consultancy company that do this an awful lot for our customers. Why would you go and use Twilio, for example? Well, a really good example of why would you use Twilio is, like I said earlier, Twilio is already in loads of firewalls as accepted. But so there's other things we want to add in. So we're going to start adding in a cost analysis. So we're going to say, right, over the last 7 days, for all of the data that we sent, and then we're going to make everything so that, like, you know, you only test 3, you only test one turn server combination. We haven't quite figured it out, but we're going to do a cost analysis. So you can see, right, if I was running over Twilio all of the time, well, my cost would be this based off of the tests that IcePerf.com are doing, whereas the cost would be less through Cloudflare, for example. So there's a load of extra stuff that we want to start doing. Like at the moment, because we test from my house, well, my ISP doesn't give me IPv6, so I'm not able to test IPv6. I could run an IPv6 tunnel, but then does the tunnel then impact things as well? So the most important thing, once we kind of got everything kind of finished up, at least on the metric side, is being able to run it from different locations, because then I can get, you know, people from all over the world to run these tests, and then we can say, right, here's a load of IPv6 data, here's some data from North America, here's some data from South America, here's some data from Asia, here's some data from China, potentially, right? Like, how does the Chinese, you know, Great Firewall affect things? So yeah, data is hugely important, and until IcePerf.com, we didn't really have any good open data about the performance of all of these of these networks. So yes, the agent itself is open source. You can go and take a look at the code today. We're in the middle at the moment. We log all of our logs out via Loki into Grafana, and then we analyze those logs. So we're in the process of moving over to using Prometheus instead, because then those stats are just automatically stats, and we can do better analysis on them. So that's where things have slowed down for the past 2 months since we launched at JanusCon, because we're taking the time to make sure that we've got a really, really good base for all of our future tests. And then the actual IcePerf website, where all of that data is all open source as well. And then what else did I want to show you? Oh, yes. So
is there going to be a client that people can run to effectively contribute to projects, so that maybe they can just send you a result of a run or whatever?
Yeah. So ultimately, you can go run that agent today yourself. The bit that's missing is, well, we need to be able to kind of know who is sending that data in, because like obviously, what's a good example? Like until you get to a really good amount of results, which obviously would then cost a load of money, right? Because you're sending data through all of these turn networks. But until you get to a load of results from all over the world, well, then you start getting into what am I trying to say? You start getting into biasing stuff. So like,
and in general, people,
depending on where you are, and so yeah, the long term goal is for someone to be able to sign up and become an agent and run that agent for us. That's the long term goal. Let me just find. I did a talk the other day. I just want to find a graph for you. Yes, here we go.
Nice.
So you'll recognize this roughly, some of those graphs that were in that website. And so this was a really, really cool thing that we found before we launched. And so what am I showing you here? So the blue bar, the blue line, first blue line is Cloudflare on turns TCP, so TLS TCP. The yellow was Cloudflare on turn UDP, and then green is Cloudflare on turn TCP. And so I only pay attention to those three colors, not because I really love Cloudflare, but because they're very different to the rest of those lines, right? The rest of those lines, let's take a look at those red lines and orange lines and purple lines. They all go up and then curve off and then flatten out. So we run the test for 10 seconds at a time because it gives us enough data to be able to figure out what's going on. And if we carried on, instead of running it for 10 seconds, instead of we ran it for 30, you'd see it completely flatten out, basically. So you go really, really fast, and then it kind of peaks, and then it stays flat. But that blue, yellow, and green line don't do that. They go up really quick, and then they start bombing down. So you can see that on that yellow one, especially. So this was before Cloudflare had actually launched their turn network. We got a private beta access to be able to test it. And we said, well, that doesn't look right, because when you did run it for longer, that downslope never stopped. It would keep going down and down and down and down. It was as though we were being punished for like always sending data. And we're like, this doesn't seem right. Anyway, we shared our results with Cloudflare, and they fixed it. So it ended up looking more like this. And so you can see that green, that yellow, green, and blue is Cloudflare. And so you can see.
It is very nice to be able to talk about it with the provider themselves.
Yeah, Yeah, exactly. We were able to share proper results with them and go, this doesn't seem right. So I said earlier, the throughput test is a weird test because who is going to be sending 60 megabits per second through a turn server? Like constantly. We send it as quickly as we possibly can, and we don't let up for 10 seconds. And within WebRTC, you get told when the buffer is kind of starting to empty, so that you can refill it. And so we get told when pressure is starting to drop, so we can send more. And so, yeah, it's a weird test because unless you are moving files, like let's say you were using WebTorrent, which uses WebRTC, unless you were using, say, WebTorrent to move files from A to B and they want to move as quickly as possible, well, even sharing 4K video, you're not going to be sending 60 megabits per second over a turn server. So it's a bit of a weird test, but kind of gets us into where we want to start going as well. Because obviously, we don't know the state of these turn networks, right? So, like, are we the only people running, because turn isn't used a huge amount. It's used in like less than 7% of WebRTC sessions on average, something like that. So it's not used a huge amount. And that's why, creating a product that purely does turn network is a tough sell, because people don't need it all the time. So you'll see that Twilio have Twilio Video. I mean, Twilio Video is becoming end of life, but they have other services, and it's the same with Cloudflare. They've got Cloudflare calls. Metered, they have other services as well. So it's the only way to make it kind of work.
I think only sources as a true. Do they only do turn? I think so.
So no, so Twilio, it's a separate product, but ultimately it's the same media IP addresses as Twilio Video.
Oh.
And so ultimately it's deployed on the same infrastructure as Twilio Video. And it's
that's smart, honestly. Like, it doesn't really matter whether it's the actual,
if it's used or not, to a degree. Yeah, it's a value add service as far as I'm concerned. So nice. So yeah, where was I going with my slight ramble about turn networks? I can't remember. But yeah,
I mean, it was super interesting. We're getting close to the end of time of the episode, so maybe we can do another. We can do another segment soon and delve more into turn.
Very, very quickly, I just want to go back to the website. Press share. And then before our time is up, RTC.on is a conference happening in Poland in September. And if you want to know more about IcePerf and where it will be in September, I'll be speaking at RTC on in Poland about IcePerf. And hopefully by then, because we're recording this in June, so by then we should be in a really kind of good place for a next update on the project. So thank you for having me today and letting me talk.
And of course, don't forget about ClueCon too.
Yes, absolutely. ClueCon happening in only a matter of weeks.
In August in Chicago, and well, we'll be all there, and it's going to be super interesting, and maybe we can talk more about the project. Well, Dan, thank you very much for joining us today. I mean, it's you always come up with something new. I don't know where you find the time, but congratulations! I mean, project after great project.
We'll see whether or not we can make it pay somehow, or whether or not it might just end up being this really cool project for open data. But I'm excited to see where it's going to go.
And I'm super excited to run a client on my Italian network and let you know how it looks like. Cool. So thank you very much, Dan Jenkins, for joining us today, founder of Nimble Ape, founder of Anycast Labs, founder of, I think, another half dozen projects, including IcePerf.com. Go check it out. Go and learn something about ice in the meantime. And, well, thank you, Dan, for joining us.
Thank you.
Rest of the people, see you next week. Goodbye.